Hello, we are now live.
Outstanding.
Yeah, thank you for joining me. It's such short notice. I literally messaged you, like 3 minutes ago? Probably less than that.
I had just finished my lunch and sat back down at my desk when I got your message, and I was like, yeah, let's do this.
Yeah, this will be fun. So we're going to take a look at QuestDB today, which is a time series database that you joined recently. Do you want to just give us the quick 30-second pitch?
Sure. QuestDB is we're the fastest open source time series database out there right now. It is blindingly fast, written from scratch, SQL-based time series database. So if you know SQL, you're already mostly there. And it's really small, actually. It's even embeddable. It's I think the entire download for it is like 3 megs, as long as you use. If you're using your own JVM, if you download it with if you're using an embedded JVM, it's a little more because you got to have the JVM. But it's really quite small. Yeah.
All right, cool. Well, I know SQL, SQL, so in theory, I should get on just fine here, right?
In theory, yes.
All right, let me bring up my screen then. I think, there we go. So this is just the website. So fast SQL series, time series, I got some Docker commands, which is great. But recently, there was the ability to deploy this to Kubernetes.
I wonder who did that for us.
Which I did out of curiosity more than anything, because I was like, hey, let's play with this. And when I built the Helm chart to deploy it to Kubernetes, I kind of looked at the UI and kicked it around a little bit, but I've not really given it some proper attention that it deserves yet. And that's what I want to do just now. So the chart is open source, of course, and it is here. So let's just have a quick look. I'm just going to copy this entire values file. I'm going to tweak it. If there's anything I don't know what it is, I'm just going to throw questions at you. Okay. And we'll try and get this deployed pretty quickly. So, I already cloned out the chart. Oh, I'm one step ahead of myself. Okay. So that's all pretty self-explanatory. The tag there says 501. Did I make that up, or is it on version 5?
No, and I think you probably want to move it to 502.
Okay. We're not going to do any tweaking here. Does the work account matter? What are these JVM options?
No. Those are not JVM options that I know of. You can leave that at 2, should be fine. Yeah.
Persistence. All right. So I'm just going to deploy this straight up. Let's just see what happens.
Yeah, let's see what happens.
Run Helm template. Metadata. I'll fix that. It's because I've got a very current version of Helm. So we're going to do upgrade, install. I'm going to have to fix that then. Always a problem on a live stream, right?
Oh, yeah.
So it's just complaining that we want a metadata tag here. I don't remember if it's going to actually...
As the CEO of a company I used to work for used to say, if the demo works every time, it's a product, ship it.
All right, let's see. I have this error, Stack Overflow, generate. I guess we can do that and copy it, can't we? Go to temp directory, run this. I need a name. Huh? Oh, that's not the right command at all. This is why you should never trust Stack Overflow. So just grab one of these charts, see what I'm missing. Nothing. Maybe I'm just reading the error too quickly for no reason. Okay, chart.metadata is required. Tell that to this chart then. So that's not been updated in a while. Let's pick a new one.
Maybe I'll learn something about Kubernetes watching you do this.
Maybe I'll actually learn how it works myself. Okay, home, maintainer, sources, keywords. Is that the metadata at once? Oh. I'm being really, really silly right now. Let's just Google the error. This is how I spend most of my days anyway.
Googling error messages, absolutely.
It's been one of those weeks where I feel like, I think I actually tweeted it just saying I spent 50% of my time banging my head off a wall and 50% of my time asking questions. It's just definitely one of those weeks. And eventually you get pretty good at skimming this stuff.
How did anybody write anything before there was Stack Overflow?
I don't know. Chart metadata. I haven't seen a definitive answer into what causes this. I'm in the wrong directory. See, there we go. I'm not even in the chart directory.
Oh, well, that could be a problem. Hey, while you're typing, I should show you this little thing I built this week. Can you see this?
Yes, it had the graph on it.
Yeah. Look how small it is. It's
what's going on there?
It's particulate matter. It's 3 micron particulate matter, and sending it to QuestDB.
Oh, cool. Okay, so we're past the first hurdle. It turns out if you want to deploy a Helm chart, then you have to tell it where the Helm chart is. Like, go figure. So.
Oh yeah, well, who would have guessed that?
It's a Friday at like 10 to 6 in the evening, so I'm going to forgive myself for that. Anyway, we're going to run kget pods, and we see that we have one QuestDB running. Awesome. So it does expose a UI, right?
It does.
Port 9,000.
9,000.
I'm just going to port forward to it, and then we'll see what we're dealing with here. So QuestDB 9,000, and we can avoid those crappy errors I was googling. This is it.
Here it is.
So do I get any metrics, like internal metrics, or am I going to have to start writing something to this?
That looks like internal metrics. So just hit run. Yeah, you got internal metrics.
Okay.
The telemetry stuff is new, and I haven't looked at it yet, so I don't know what what exactly you're going to be getting. If you want to send data to it, you're going to have to expose port 9009.
That's not on the chart. So are we missing a port from this?
The 9009 is both a TCP and a UDP port for influx line protocol.
Oh, that has its own port, right? Looks like the chart's getting a pull request this evening then. So we'll call this InfluxDB container port 9009 and protocol TCP. I don't know if you can add that twice. Does it listen? I can't listen on both, does it?
It will actually, well, I don't know, on my machine, it will listen on both ports as long as one of them, as long as they're different, it works on my machine, so I guess we should ship my machine.
Oh, it seems good. I didn't know you could do that. See, I'm learning too. All right. So we describe this. We go to, is that not this port? What's port? All right. Okay. Yeah, it's just taking the TCP. That's fine by me though. So
yeah, that's yeah.
All right. Telemetry data is no fun. Let's get something else in here. Torn. Do we want to stick in something big, or do we want to just kick the tires a little bit?
Well, you can just, if you just turn on Telegraf, it automatically starts collecting just a ton of stuff, right?
Yeah, you're right. I'll probably do it inside the container though. I'll deploy it via Helm, or should I just run one locally? Do I even have Telegraf?
Totally up to you.
I see how slow this is. We can always just do that. And I'll just quickly put together Telegraf configs then. So agent, interval, and input CPU, mem, disk. Let's take a look at that. And I'm using the InfluxDB output.
No, actually, you're doing the output. I believe it's the socket. Let me look. Oh, I don't. Yeah, I'm gonna have to.
That's all right. I can pull up the docs here. Telegraf, GitHub. So I just need to send lane protocol on a TCP socket, right? That's it. So I can work that out. Writer. Copy that. So we want to write to TCP 9009.
Yep.
And because this is Kubernetes, we're going to take advantage of their services, which means our QuestDB is available. And we'll need to expose the extra port, but that's fine. And I'll push these changes up as a PR to that chart for others.
Okay.
So, which means we're just looking for QuestDB 909, and I'll probably need to set the data format.
Yep.
Anything else?
That's it.
Okay. In fact, I installed this for Brew, so we're not using that. So we'll do that later. All right. Let's see what happens if I run Telegraf config Telegraf and port forward that extra port. So QuestDB 9009. Right, so Telegraf isn't moaning yet, so that's maybe a good sign.
That's a good sign if Telegraf's not either moaning or crashing. So just hit the.
I need my second port forward to the web interface.
Oh yeah.
Well, look at that. All right, so what's this table in QuestDB? Is that a measurement in Influx?
Basically, yeah. Basically, yeah.
I can just run this. Ooh, there we go.
And there you go.
Cool. All right.
Now,
So,
here's something that I didn't know when I did this the first time, was that if you actually create the table first and designate a timestamp column, then some of this Telegraf stuff doesn't work as well, because Telegraf occasionally tries to do an out of order insert.
oh,
And if you have a designated timestamp column, then you can't do, right now, you can't do out of order inserts.
okay. All right, I'll try not to do that.
Well, yeah. But we're fixing that. Actually, Vlad's been working on out of order inserts lately, and he hopes to have that done pretty quickly. We also are hoping that our Grafana plugin will be ready pretty quickly.
Okay. The copyright down here says 2014 to 2020.
Yep.
So QuestDB's been around a while?
Absolutely. Yeah, 7 years actually.
Was it always open source, or is that something that happened recently?
I'm not quite sure when. I think it was mostly open source. Vlad basically started writing this in his spare time. And he wrote it, and he wrote it, and then he was like, oh, well, you know, what I did was shit. So he threw the whole thing away and started over again and rewrote the whole thing. And because he was trying to get basically the performance as close to the hardware as possible, right?
Okay. So, all right, teach me then. How do I do some time series stuff? How can I calculate, how can I just pull out a single field? We said this is SQL, right? Can I just select
Yep.
and go usage idle from CPU?
Yep.
Work.
Yep. Boom.
Okay.
If you want to see the timestamp, then select CPU idle and timestamp, right? So.
Okay, so, well, I'm going to need the CPU. I want usage idle and then timestamp. I'll just comment that back out. I like that I can just command and slash the comments. Oh, let's get these away.
Yeah, Merrill did a really nice job on the editor for this.
Yeah, that's good. Okay, let's try something else then. So
if you click on that button down there that says chart. So for labels, under that labels pull down, choose timestamp. And remove timestamp from the series there, and now hit draw.
Move.
It's a bar chart. Change it to a line chart and redraw it.
Okay. So this is all right. Okay, I got it. So
it may be that you're pulling. Go back to your grid view, the table, and see.
Is it because there's 8 CPUs? No, 16 CPUs.
So that's why it looks like that. Yeah.
Okay. So can I group by?
Do a where CPU 0 where CPU equals CPU 0.
That?
Single quote. Yeah. So now you only have CPU 0. There you go.
Okay. That's what I would expect, right? Value changing over time.
That's a little more reasonable. What you were seeing was 8 CPUs all drawn in the same color.
All right. So how do I calculate the mean then of all my CPUs? Can I do? Let's see. Let's take that off. Can I just do mean?
Yeah.
Oh no. Mean not found. So how does this document?
Yeah, try lowercase.
I think that red squiggle means bad though, right? Yeah.
Yeah, the red squiggle's bad.
See, I know that. I get that in my code all the time.
You can do average.
Yeah, average will work.
Yeah.
That just AVG. Yeah, there we go. Okay. Let's do that. And that's only going to give me CP.
But you're in chart mode, so go back to grid. There you go.
It's because I took off the CPU and timestamp is still there. So.
You can also do right. You want to take out? Yeah, there you go. Here's your average.
Okay, so if I had to move the where, that will give me the average of all CPUs.
Yeah. And
will I get 1 series or will I get 16 series?
I don't know. You don't even need this.
All right. Okay, so I've got the average per series. I guess that feels natural. That's what I would expect. I'm trying to work out what would I do if I wanted to group all of those together and calculate the average then? Just group by, or would that group by the value of the CPU?
So basically, our group by is no op because it automatically groups.
Okay. So let's see. If I type group, we get this lovely documentation page. That's pretty nice. Okay. I can group by sensor ID. I can do multiple fields on the group by. Okay. Oh, nice. And I take it you have this for, oh yeah, all the functions are here.
Yeah, we got all the supported functions there.
Oh, a show statement. I can introspect the database. Let's have a
That's how you get the. That's how the tables are in that side You'll notice that that looks exactly like your little sidebar there.
It does.
That's how we get that. Yeah.
Show columns from disk. Ah, cool. Okay. I like playing with new tools.
What's that?
I like playing with new things and just, that little bit of joy you get when you work at something else or learn something.
Yep.
So
what you'll notice there is that we're using symbol and not string.
And what does that mean?
So here's the thing. The way that one of the way, and I just had like an hour-long talk with Vlad. I'm in the process of writing this up as a blog post because it's super interesting how he did this. Everything is stored as 8 bytes, right? So everything lines up on 8-byte columns, right? So that it's really, really fast because we know exactly where everything starts and stops, right? But strings are weird because they can be any length. So you can't store a string in exactly 8 bytes unless you're only going to allow people to store 8 bytes worth of string data, which is kind of limiting. So what it does is we store it as what's called a symbol. And what it actually does is it puts the string data in a different table, and it stores basically a pointer to that string in the 8-byte column. So it keeps everything lined up by 8 bytes, but now we know exactly where to go to get the value, right?
Okay.
And it speeds it up a lot.
Right. That makes sense. I got it. I got there. Just took a bit of time.
So one of the other things that we talked about yesterday, I talked about yesterday with Vlad and Patrick, one of the other engineers, is what they had been doing was, basically we're memory mapping everything, right?
Okay.
And what they had been doing was creating pages in memory map of memory map, and then when you get to the end of a page, well, they create another page, and there were all these like if then else's to figure out which page stuff was on and where stuff went on page breaks. And what they did just like a week or two ago was they instead of having multiple pages, they just decided to make one ginormous page, right? 2 to the 64th, because it's a 64-bit database. One page that's huge. And then they don't have to try to decide what page they have to look in because it's all in one page. And they don't have to allocate the whole thing. They can just, when it gets full, they just, grow the same page bigger. So they don't have to worry about where the page boundary is. There's no more page boundaries. And it turns out that if, all that branching around if this is in a page or if it's in the next page and going from page to page was really slowing things down. They got something like a 60% speed bump by doing this page thing. And they're doing something that I'm kind of amazed. I asked Vlad yesterday, I was like, why didn't anybody else think of this? Because a lot of other databases basically try to outsmart the kernel and do a lot of this stuff, themselves. They take the job away from the kernel and try to outsmart the kernel. But really, this is the kernel's job, right? Is to know exactly where everything is in memory and on disk and how to get there fast. And so why not just let the kernel do its job and not try to, take a bit of memory from the kernel and map it sideways into my database, and then I have to reference that, which references into the kernel, which gets the memory address, right? It adds another layer of indirection. And so they're not doing that. They're basically just letting the kernel do its job and not trying to be smarter than the kernel, which you're not going to be, right? You're basically not going to be smarter than the kernel.
Okay. I think that's a very good take-home lesson. Don't try to be smarter than the kernel. So you kind of touched on performance with that. Like, if I remember right, was it a month ago? You made like was it 1 billion points database public? I can't remember the details. Do you want to?
Yeah, you can go. You can actually go there right now. It's still live.
What's the URL?
Try.questdb.io port 9000.
This is just a public QuestDB. And how big is the data set?
1.6 billion rows. If you just click on, if you just run trips, run that. So you got 1.6 billion rows in, what'd you get, 3 milliseconds?
Execute 3 milliseconds, network 28, so yeah, total 32. It's pretty fast.
3 milliseconds to go get 1.6 billion rows. And there's some sample queries up under there under example queries.
Ah, okay.
So you can actually do an average over all 1.6 billion rows, like the average distance, right?
Well, let's do the average fare keyed by passenger count.
Right.
So I go. So that's then works out how many people were in each of the cab rides, and then works out the average fare.
I'm still trying to figure out how 0 people in a cab cost average $10, but I'm you know, and what was the speed of execution of that?
So that was execute 449 milliseconds.
Right, and that's not a simple query, right?
No, it's not. Definitely not. Cool. So the average.
And that's over 1.6 billion rows.
Let's see what else we've got. So, is there a command line interface, or do you have to use the web interface?
Right. Well, so you can basically do a command line interface, but it's basically you're running it via curl, right?
Right. Okay.
We don't have a straight command line interface.
And what's okay, let's just. I'm just going to do this actually because I want to see what the output is. I'll do my local one rather than.
Oh, so it actually there's 2 endpoints for if you.
We can just steal it from here, right? There we go.
Yeah, and it's either, depending on which endpoint, it's either returning a CSV or it's returning a JSON.
So if I say, is that not normally a copy of curl? What's here? No. Oh, there we go. So let's pop over here. I'll just grab a new tab, temp directory. So you hit the exec endpoint, just pass a little bit of metadata, columns. Oh no, wait, that's just a query. So show, okay, yeah.
So I believe, I can't remember, there's an exec endpoint and then there's an EXP endpoint, and one of them returns CSV and one of them returns JSON. It looks like, is that one returning JSON? Yes.
Yeah, that's we can put it through JQ. So what am I doing? And JQ. There we go. Oh, nice. I like it when things return JSON. It means I can.
What's that?
I like it when things return JSON because it just means it's so easy to script against that. It's so easy to consume it and use it and forward it onto other functions. So.
Yeah, it's really easy to deal with. And the other endpoint will give you CSV if that's what you want.
Which endpoint is that?
Now you're asking hard questions.
That's okay. It's not important. I got what I needed. I seen some JSON and I executed a query in the command line. So that's progress for me. All right. What should I be aware of? Like before we wrap up, then, like, what have I not asked? What have I not covered? What do I need to know about QuestDB?
In terms of like things to avoid or things to do, or
no, just even superficially. Like, is there anything that I've not touched here that's really cool? I mean, I've just kind of thrown a little bit of data at this and
Yeah, I mean, so I've got a version running here on my laptop that I've been sending IoT data to, and it's got sort of like 2.3 million data points in it right now. And it's still like, I'm getting, millisecond level responses to queries on the data. So it's one of the things that I really like about it is that it's really small and it's really fast. So it's got both small and fast. And it's, as you see, well, I mean, I don't know about Kubernetes, but it's super easy to deploy because you basically just start the binary and it runs, right?
Yeah, the Kubernetes deployment was, it's pretty standard. I think I wasn't aware of the InfluxDB protocol, so I need to go and add a few things, but
right.
Pretty simple to get to.
We had InfluxDB line protocol for UDP for quite some time, but we just added the TCP version of it, which actually has made a bunch of the stuff that I do for IoT really a lot easier because I don't have to. With UDP, I basically had to keep opening and closing the connection because you never know. And with the TCP one, I can basically open a connection and it'll stay open for literally days, and I just write data to it, right?
Ah, that's pretty cool.
So I write data to it every second, and it just takes tons and tons of data.
Okay, yeah, it definitely sounds interesting. I mean, when you say that it's small and fast, like right away, I'm like, but it's a JVM. And it doesn't compute to me, but I can see that it's small and fast. It's just not something that I'm used to. And I guess I'm not that. I haven't played with the GVM a lot over the last even probably 10 years. So I'm not sure it's changed for the better drastically.
So look, I started with Java in 1995 before it was called Java. So I'm well aware of it's interpreted so it's slow, right? But starting really in the sort of the early 2000s, maybe, with some of the just-in-time compiling, and then certainly by the mid-2000s, you were getting near native speed out of the JVM, right? I worked on a very large storage project at Sun Labs, and they wrote the whole thing in Java, and they were actually getting better performance out of Java than they were out of the stuff that they'd written in C, right? Which shocked me. I didn't think that was possible. And one of the things that Vlad has done here is that one of the things that gets you with the JVM is garbage collection, right? Because you never know when the JVM is going to say, hold on a second, I got to collect garbage, and it's going to go away while it collects garbage. This is zero garbage collection. So the JVM never stops to collect garbage because it generates zero garbage.
Wow. Yeah, C++ and zero garbage collection Java.
Yeah.
Tiny memory footprint, vectorized query execution. I don't really know what that means, but it sounds really impressive.
Well, basically, the queries are run in parallel, right?
Ah, got it. Okay, cool. And I guess that fits nicely with the SIMD then, the fact that you can execute, single instruction, multiple data, right? So you're executing the same thing across data in different points of memory.
Yes.
I think that's how it works. Okay.
Yeah. And that's one of the reasons that some of it is written in C++, and is that the performance of it is very, very, very closely tied to the performance of the hardware, right? So the faster, it's always true that the faster your hardware, the faster your whatever it is going to run. But this is really, really close to, sort of optimal hardware performance, because of how closely aligned it is to memory boundaries and such, so that it gets just maximum performance out of it.
Very cool. I'm just looking at these sample queries, I guess. So this syntax here, this is obviously some sort of magic string. So it's saying where timestamp is what, greater than the 14th, but
minus 2 days.
So does that mean it goes from the 14th to the 16th, or the 12th to the 14th?
It goes to the 12th to the 14th.
Nice syntax. I guess the sample by, is this for doing windowing?
Yep.
Nice. Latest, does that just get me one value?
Yeah. From that set, from that one.
Latest by. Oh wait, that's a show call. Oops. Let's do something actually useful. So
yeah, let's show columns isn't going to be so helpful, is it?
What was it? Usage idle from CPU. Ah, sure. Okay. If I kept the CPU, and I guess that would probably make more sense. But the syntax is good. And what's this last one? As of join weather.
So that will join the two things together. It's basically it's a kind of join, and don't ask me about as of joins because I'm terrible at this. my SQL is old and rusty, and it's just getting back up to speed. But I believe that you can run that query. Oh no, it's sensors. There is in the try demo, I believe there is one that's an as of join.
I mean, I'm going to try and just do it first out of complete curiosity. So if I do as of join, can I bring in disk? Or does it need some sort of joining field? Ambiguous column name. Now, I'm assuming that's because the timestamp exists on, no, both? No, let me check. So CPU.
Go look at the QuestDB demo and see if we can find an as of join in there.
Host. I know it's host. I want to hack it before I go look up the demo.
Okay.
So how do I disambiguate then? Let's see. That doesn't have any. I don't even want a host. Ah, drats. All right, let's go look it up. So, yeah, there's an as of there. So we're saying select all of these. Oh, you can do math inside the select. Cool. From trips, as of join gas prices. What's that doing? Oh, I broke it.
Just go reselect the query and rerun it. There it is.
I'm sure I just typed something by mistake and broke it. So this is grabbing cab type, which I guess is coming from the trip. I don't know. And then adding on the gas price.
Yep.
Okay.
And it's joining, and it's basically, I think it's joining them on the pickup date and time. Yeah.
So I won't put you on the spot because I know it's a tough question, but I wonder how I can disambiguate that host field so that I can do that join.
What's the error? I can't really see the error it's giving you when you try to run that query.
Oh, sorry. So it says ambiguous column name, and that's because both the CPU, I'm assuming, you can correct me if I'm wrong, the CPU and the disk tables both have a host column. Maybe if I just...
no, it looks like it's complaining about the timestamp.
Oh.
That's the one that's under that's squiggled.
Right. So if I just take that off, and now it's saying I have no timestamp.
Right. No, put the timestamp in the ASF join.
Like comma timestamp or?
Yep. Nope.
No, it doesn't like that. Let's try the documentation. I just spend 30 seconds on this and then we'll just wrap up. I don't want to. I actually, if you had 20 minutes and we're currently at 42 minutes into this. So. Okay, so select as a join. Yeah, there's maybe too much for me to try and consume here in this short space of time. I will play with that later, I think.
Okay.
Anyway, it seems cool. I like it. So before we finish then, like, does QuestDB have cardinality problems?
No.
That was the fastest no I think I've ever heard.
So you mean I didn't answer with it depends? No, because it's a columnar data store, right? So one of the problems with cardinality that you ran into with, say, InfluxDB was that it basically created a series for each tag and data sets, right?
Mm-hmm. That's correct.
And so that's where you got your cardinality, was the number of tags and the number of values, right? That's the sort of the easy calculation of cardinality, is you multiply your tag set by your value set, and that's your cardinality, right?
Right. Okay.
And
I guess.
So what happens in QuestDB is, if you have a table like this and you start sending, let's say you have a sensor, you're sending all your sensor data to the same table, right? But not all your sensors are sending the same values. Any missing value will just be filled with a null, right? So you'll have a table that is wider with lots and lots of columns, but a bunch of them are null, depending on what values are coming from what sensor.
Right. Okay.
And again, everything is on these 8-byte boundaries, so it's super fast to go search through them.
Okay. Interesting. So I think my interest is piqued. I'm going to play with this more. I won't take up any more time today, but I mean, if you're happy to, and I'll put you on the spot and ask you here, but when the Grafana plugin goes live, we'll do this again, and we'll have a play with that.
Absolutely, yeah. Trust me, I am like chomping at the bit to get the Grafana plugin, my hands on the Grafana plugin. I'm going to go poke around in the and see if I can actually grab it from GitHub and build the buggy version that's barely working myself and make it work.
All right. Well, thank you for joining me. I look forward to our Grafana session, and enjoy your weekend. I'll speak to you again.
You too. It's great seeing you again.
Yeah, you too, David. Right.
Okay.
Bye.